So one of you can confirm whether I'm audible or not. Anyone? Am I audible? Okay, so basically what I want you guys to speak up, right? Yeah, it's okay to put messages to the chat box, but I prefer to have you speak on while the lecture is going on, right? Okay, ඔයගොල්ලෝ කතා කරන්න ඕන lecture එක යන වෙලාවේ. හරිද? මොකද chat box එකට දැම්මහම මම chat box එකට ගිහිල්ලා message එක check කර කර බලන්න ඕනේ. So it's much better if you can speak up by unmuting yourself. Right. Okay. So welcome to the lecture module of Mathematics 1. I hope this might be the first online lecture that you will be having. Ne? එහෙම නේද? පළවෙනි lecture නේද? Isn't it? Yeah, it has to be interactive. හොඳේ. ඕගලන්ට උත්තර දෙන්න බය වෙන්න හේතුවක් නැහැ. So you can answer, right? Because it's not worth I will keep talking without having you guys involved, right? Okay. So මම විතරක් කතා කරන එකේ තේරුමක් නැති නිසා අපි බලමු ඉතින් interactive විදිහට මේක කරන් යන්න. හරිද? So this should be your first lecture නේ. පළවෙනි lecture එක නේද ඔයගලගේ? Right. Isn't that if I'm not hearing you, or I suppose no one is speaking, right? Right, somehow. So I will go with the formalities then. So I don't have to talk about right. So I'm going to stop my video here because we will have some interference with video as well as presenting together. So yes. Right. So in this particular course, we are going to learn about the first mathematics module that you will be needing in your future career, right? So in this particular mathematics career, right? I mean, mathematics course, we will start with some sort of prerequisites to what is going to be the main module, right? So in your main module, we will have 4 different topics, right? We will have 4 different topics, right? Matrices and determinants, right? And then we will have vectors, and we will have differentiation and integration, right? So basically we can have differentiation and integration as two lessons, right? So before we do the differentiation and integration, we will have small portion which is called limits, right? So basically these 3 parts. Yes. Does anyone have a question? Right, somehow. So these 3 topics creates the calculus. Calculus කියලා කියන්නේ කලනය. Right? Calculus කියලා කියන්නේ කලනය. Right? So basically these are the 4 topics that we will be discussing, right? Matrices and determinants, න්‍යාස සහ නිශ්චායක, then vectors, දෛශික, and then 2 topics of calculus. කලනයේ කොටස් දෙකයි, differentiation, අවකලනය, integration, anukalane. So these are the 4 topics that we will be doing, right? So basically, if we are going to learn differentiation, integration by means calculus, we will have to do something in some, right? O level වලට ඉගෙන ගත්ත sets ටික ඇති. ඊට අමතරව පොඩි පොඩි notations ටිකක් වුමනා වෙනවා. So I will teach them on the way, right? And then we will have to go for algebra, right? Basic algebra parts, right? Basically, you guys did a hefty amount of algebra. You have done a lot of algebra during your grade 6, 7, 8, 9, 10, and 11, right? So we will use few of them in our case, right? And then we will be learning some parts of algebra, and you need some sort of geometry also, right? So you need some sort of geometry skills, right? So geometry skills are also important in learning calculus, right? So in between algebra and geometry, we will have trigonometry. But in this course module, I'm not going to teach you much of trigonometry, just a teeny bit, right? Very small amount. I will discuss only small amount of trigonometry, right? So it will basically for the differentiation and integration only, right? Okay, so that's how it usually goes. And along the way, you will have 2 to 3 CAs, right? Continuous assessments. And then probably if you guys are not attending properly, you will have a mid examination also, right? If you are not attending properly for the lecture, right? So this depends on you. Mid examination is purely because you guys are not attending to lectures physically or online, whatever the manner. If you are not properly attending the lecture series, I will decide to have a mid examination, right? So this lecture module will be conducted by myself and Mr. Niroshan, right? So I'm Kavindra, as you already know, right? And Niroshan. So we are going to do this module. So I will start things up, and later I will hand over some parts to him, and he will conclude the lecture series, right? And you will have 2 to 3 CAs at minimum, and then based on your performance, you will have mid examination. Ogolange performance mid examination at the decide, right? And then you will have final examination, right? Final examination. So usually you will be allocated 70 marks for the final examination and 30 marks for the continuous assessments and mid examinations, right? So this is how your final examination marks will be evaluated. So you will have an essay paper. So you will get usually 7 questions. Out of 5 you have to do. So you will get around 500 marks, and it will be divided into 100, right? And then out of 100, you will get some sort of amount. And from that amount, you will be considered for 70% of marks. And here, depending on the CA marks also, you will have somewhere around somewhere in between 100 and 0, right? Let's say this is X and this is Y, right? And from out of this Y amount, you will get only 30%. So basically, this X and Y values should be at least more than 35. 35 is minimum for essay, right? And then for CAs, 45 should be your minimum, right? So if you are not able to score at least 35 marks, you will receive ESA, right? If you not score 45 marks, you will receive ECA. In either case, you will have to write your examination once more, because this means that you are not eligible to I mean, you haven't completed your course by achieving the given intended learning outcomes, ILOs, right? So if you haven't met with your ILOs, you will be repeated, right? So you will have to take the examinations or the CA marks, CA separately, or maybe you will have to sit for the both of them, right? So this is how usually it has to be done, right? And for your references, right? For your references, so you can refer to any high school mathematics textbooks. And then you can go for a specific book by Sullivan. So this is algebra, as I can remember, it should be algebra. And it should be algebra and trigonometry or something like that. Algebra and trigonometry. So I will just put it here, algebra and trigonometry, right? Okay. And then you can follow any calculus book, right? So in this case, you can go for some open source ones, right? So you can just give me just a second, right? So you can use some open source books that are in different publishers. Basically, you can go with calculus by James Stewart, if I'm correct, right? So it's like calculus early transcendentals, or not, something like that. Let me check it further. Early transcendentals, right? Steve, Steve Watt, James Stewart, right? Stewart, right? So these books are more than enough for you guys to do, and you can always use them. Socium's outlines, Socium's outlines. So I can remember that name. So let me check. So it should be SCH. Yeah, it's difficult right now. SCHUMS. CHU CHAUM. Socium's outline series. So you can find any calculus book on this particular 4 parts, right? So if you want these books, you can either contact me by your representative. If I have these PDFs, especially the Sullivan and James Stewart books, I can share them among you. Right? But basically, these two should be available to freely download, right? Sullivan's algebra and trigonometry, right? Okay. So now today we will have a small introduction to your lectures, right? So we will be starting with numbers, right? So basically, how did we get the concept of numbers, right? So our ancestors, they did not have the Hindu number systems, right? Roman number systems, right? But they were able to do the counting, and there are evidence for that they have done these sort of counting methods, right? So they had ropes, and they were using notes to show how many plants they were planted on their field, and they used pebbles on sand to show the number of traps set for fish. And then they were farming, they were controlling, and they were having animal farms, and to record the number of baby cows or baby lambs that were born, they use a stick, and they used to create a mark on those branches using a knife, right? So that's how they were counting things, right? So basically, once they had uh, the animals, right? We know that they were eventually controlling those animals as a farming method, and they wanted to have a count how many animals they owned, right? How many were there in the herd they got, right? So it was like yeah, basically, guys, if you are expecting me to explain in Sinhala, I will try, but what I am asking you to not to be get trapped into learning in Sinhala here, right? I can explain in Sinhala, but you will be all the time looking for a Sinhala explanation. So you will not learn. ඔගොල්ලෝ Sinhala explanation එකක් බලාපොරොත්තුෙන් හිටියොත් ඔගොල්ලෝ හැම වෙලේම සිංහලෙන් අහන්න සූදානම් වෙලා ඉන්නවා. Right? Yes, that's why I'm giving you some textbooks, right? So what you can do is that you can look for the textbook, and you can have photocopied, or you can write your own notes, right? So what you can do, you can go through those English words and get familiar, right? So so I can babysit you, right? But it's not how we should do, right? There is no excuses that you can't understand English, that you are not familiar with English, right? So I can understand the problem, but I believe that once you ask a lecturer to explain in Sinhala more and more and more, so you will be reluctant to learn in Sinhala all the way, right? At some point, you will have to change into English. So try it from the beginning, because mathematics is the best thing to learn in English, because maths parts has to be done as maths part, right? So the best thing that you can do is try to learn these things in English, and then please go through the given resource books, right? So that's how you can develop your English also. දීලා තියෙන පොත් බලන්න. References books දෙන්නේ ඒකයි කලින්, right? So I can teach in Sinhala, and if I'm teaching in Sinhala, it will be really disadvantageous for the students who learned in Tamil, right? Tamil වලින් ඉගෙන ගත්ත කට්ටියත් ඒක එක්තරා විදිහක අසාධාරණයක් වෙනවා, right? Yes, you can argue that, okay, if you are teaching in Sinhala, then most of us can understand, but it is not how it is, right? So I will try to clarify things many times, right? But what you should do is that you should try to understand things in English. Yes, I know that it's difficult for you, because you said that you have learned in Sinhala for most of large amount of your life, but the solution is not I'm explaining in Sinhalese, right? Okay, so I will use some simple words. I'm not using big difficult words. I'm using simple English, right? Okay, and give the attention to the lecture slides. So usually I'm using images to explain many things, right? Okay, right? මම සාමාන්‍යයෙන් images use කරනවා explain කරන්න. ඒතර ඕගොල්ලන්ට ඒක බලාගෙන ගත්තා නම් හරි. Yes, I will. I can share you the reference book. Please ask your representative to send me an email. ඔයගොල්ලන්ගේ representative කියන්නේ email එකක් එවන්න කියලා, right? Because yes, you can check for the references books, so you can take a screenshot here, and if you may want to look in those books, yeah, I will just try to. Yep. So this is a one book. This is another book, right? These two books are more than enough for you guys, right? So these two books are really good, especially the Sullivan's book, and especially the Sullivan book is good for the learning of algebra and trigonometry. And for the calculus, yes, you have to go with James Stewart calculus book, right? So you can search them, right, Sanka? And also we need your contact number, right? So please contact us with your contact number also. Right. So I was talking about how early people used to count the properties they had. Ne? So the how many animals they had, how many traps they have set, how many plants they had planted, right? So they were using some sort of symbols to represent each animal or each trap or each plant that they have planted, right? So for an example, let's say they have a buffalo herd, and for each herd, each buffalo, they had a stone representing itself, right? So let's say they had 50 buffaloes, then they had 50 stones with them. So then they can have a record of how many animals they had with themselves, right? So what would happen if they had no animals? So somehow, let's say one night some wild animal attack happened, and then all the animals they had were eaten by them, right? Then no animals. That means they don't have to keep any stones. So how can we represent that the emptiness, right? How can they represent the emptiness? So then let's say if you were able to count naturally, right? So now we know that we can count 1, 2, 3, 4, 5, 6. So we are naturally counting. Ne? And then what is the concept here? What is the concept here? No animals means? So this is the concept of zero. Ne? Who invented the concept of zero? Right? Who invented the concept of zero? So what you can do, you can search for the evolution of number systems, right? Evolution of number systems in YouTube. Right now, you are Gen Z guys, and you know most of the social media platforms, and you can search for evolution of number systems. So you can find who invented the concept of zero initially and who developed it, and what is the importance of having the concept of zero, right? So those things are part-time things that you can try. Okay, so please go and check, right? So no animals means no stones, and the symbol should be zero, right? And then with the time, the humans, they were trading with each other, right? So especially we know that there were several trade roads like Silk Road and some other trade paths, right? So once the trading comes into the action, right, as well as in local cases, right? So then when they were changing goods, or when they were changing goods instead of having money. So there were some practical problems, right? Let's say someone had excessive amount of produce and they received less amount of goods in return, right? So let's say I had 10 uh, products produced by myself and the person I'm exchanging with had only 6, right? Then I will have 4 extra and the person who shared with me had 4 deficient, right? Deficit. So now there is a practical problem. How can we keep the record of debts and losses, right? Losses, we say that if we had if we had 10 fruits and 4 of them were wasted, right? Right? So then how can we record these losses and the debts? So we have to represent the values below 0, right? Initially we had natural things and then we had to introduce 0, right? And then we have to introduce the values below 0, right? So-called negative numbers, right? So this lays some foundation for our number system, right? This lays the foundation of our number systems. Let's look it furthermore, right? See now. So now we have natural numbers here. Natural numbers are here. Natural or counting, both of them are natural or counting. And then we had whole numbers. So what we have added to the whole numbers is 0, right? We had natural numbers 1, 2, 3, so on. So then we can have 0. So 0 with natural numbers creates the set of whole numbers, right? And then we had the negative numbers, right? To show the deficit of something. Altogether, negative numbers, these counting numbers or positive numbers and 0 creates the integers, right? Creates the integers. Integers are shown in the symbol of some decorated Z, right? So this is integer. In the case of integers, we have positive integers and we have negative integers, right? And then, so let's say that we had a cake, right? This is a whole value. We have a cake, an integer, and we wanted to cut it into similar 4 portions. So what do we get here? What do we get here? If we want to cut a cake into 4 pieces, what do we have here? What is the portion that we have here? It's 1/4. Is it true? So here we had a whole cake and we cut it into 4 pieces, right? So this is a quarter of a cake. So this particular part where we can represent any number using P divided by Q, right? Q should not be equal to 0. P and Q are integers, right? So-called rational numbers, right? Okay. If we can represent something using 2 integers as a ratio, ratio, right? Ratio. So using this ratio, we can have rational numbers. So let's try some of these. So can you find out the value for 1/2? What is the value for 1/2? Let me know what is the value of 1 over 2. How much? 0.5. Value for 1 over 4. 0.25. 1 over 8. 0.125. 4 over 5. 0.8. 1 over 3. Okay, now I see some changes. Someone says 0.33. Someone says 0.333. Some says 0.3333. So what is the correct one? What is the correct one? Yeah, 1 over 3 is rational. 1 over 3 is the P over Q times. Right? So if you had 0.3, what is this? See, 0.3. Let's take one by one, okay? Okay, let me change the color here. Right. Let me use a different color. Okay. Some say 0.3, some say 0.33, some say 0.333. Right? So let me take x equals 0.3. Right? So 10x equals how much? 10x equals how much? It's equal to 3. Ne? So then x equals what? 3 over 10. Is it similar to 1 over 3? Is this equal? Is this equal? මේ දෙන සමානයිද? No, this is not equal. So let's check with x equals 0.33. So what we can take? 100x. How much 100x is? 33, ne? So then x equals 33 over 100. So is this equal to 1 over 3? No. So if you want to write down something similar to this, so now you can see that 3 is going to be repeated. Ne? So you can use 3 dots here to show this is a repeating one. Right? So here we can have it up to 1 decimal point, right? Decimals, right? So these decimals are going to be terminate, right? So we don't have anything beyond here other than zeros. Ne? From here it's ended. From here it's ended. From here it's ended. Right? These are terminating ones. These will terminate eventually. But these are repeating decimals, right? These are repeating decimals. Can someone find the value for 1 over 9? What is the value? Yeah, then it should be 0.9, not 9, it should be 0.11 or something. 0.111. It's repeating itself. 2 over 7. I need up to several decimal points. At least 5 to 6. Two over 7, someone please. Right? So if we take it as, it should be 0.285714. And once again, 285714. So you can see that 285714. 285714. 285714. So this is repeating. Ne? Right? So to write them down, you can use 2 over 7 is equal to 0.285714. 2 is going to repeat and it repeats end at 4. Right? This is how you can write down a repeating decimal. And for these things, it's really simple. It has a repeating 3. Repeating 3. Right? Repeating 3. These two are not same. 0.3 and repeating 3 is not the same. These two are different from each other. Right? Okay. So now you can try 5 over 6. What will happen? It will be 0.83333, something like this. So we can write it as 0.83 repeating, recurring, right? Okay. Is it clear? And how about 1 over 11? Yes, it will be 0.0909 something. So it is going to be something similar to this, right? So you can write any amount of repeating values here, right? So now, is that all? Is that all? Right now, I have some examples for you. So I have isosceles, Samadhipada Trikonayak, right? Isosceles, right? Isosceles, right angle triangle. So that means these two sides are equal. Let me say this side is 1 centimeter, this side is 1 centimeter. So what is this value here? What is the value of hypotenuse? Karne age kiyada? Yes, it will be root of 2. So what is the value of this one here? What is the value of here? You say 1.41. Is it all? හොඳට බලන්න තව decimal points එකක් දෙන්න බෑ. Give me some more decimal points. Can you find some repeating pattern here? Can you find some repeating pattern? No, it seems that this is not going to terminate. Ne? So square root of 2 is equal to 1.41421356237309504.8. So it doesn't going to be finished. So this is non-terminating ones, okay? Non-terminating. Eh? So that means, so I can show you something. So we could have represent these decimal points in a rational way, right? So every decimal point, if it has a pattern, right? See, I can show this one here, right? This one here as a rational value. See here. So let me take x equals 0.83. And then if I'm correct now, because 83 after 3 we have repeating 3's, and then we take 10x, so we will have 8.33 and so on. So what I can do, I can reduce these values here. So I'm going to reduce the two values here. Actually, yes, not this way, right? Okay, and then we have 100x, which is 83.33 and so on, right? So what we can do, we can subtract 100x and 10x, so we will get 90x, and here we will have 83, and for the decimal parts we can cancel them out because all of them have 83s, and here we have 83 divided by 83 minus 8, that means 75. That means 75. And x is equal to 75 divided by 90. Right? So this will be 5 times 15, 6 times 15. So we can rewrite these decimals that we had earlier as a rational number. But can we do this? Because we can't find a pattern. Here we could have find a pattern. Here we could have easily find a pattern because it's repeating some set of numbers. And here, if we could have used this one, see here. So let's say x is equal to 0.0909, right? So that means we can take something similar to this. So then I can multiply it by 100, 100x equals 9.0909, right? And then I can subtract them. So I will have 99x equals 9. So x is going to be 9 over 99. That means 1 over 11. So these repeating ones and terminating ones, we can write them as a fraction. But these non-terminating ones, we can't write them as fractions. We can't write them as rational. We can't write them as p over q. We cannot write them as p over q. So they are called irrational numbers. Irrational numbers. Right? So we had rational numbers, right? And then we have irrational numbers like square root of 2, square root of 3. And then let's take a circle, right? So we know that circle circumference and the diameter. If we divide circle circumference by diameter, we will get 5. And we know that c equals 2πr. So 2r means d, diameter, 5d. Right? So phi is equal to c over d. Right? Now, whether think that we have represented this c over d, right? This is c over d, but this is not a how to say, this is not a rational number. This is irrational because we encountered with phi, right? Because this number is not going to be, phi cannot be represented to a particular repeating or ending value, right? Even though we represented this one as a rational value, so this is not a rational one, okay? So this is approximately true, right? Okay, C over D, right? So that's how it happens, right? Okay. So any idea other than these values? What are the rational numbers? So we have E. E is once again irrational number, right? E means what? E means what? E means what? Irrational numbers. E means what? E is the Euler's number, okay? E is the Euler's number if you don't know Euler's number, right? So you can find out many irrational numbers, right? So basically, the amount of irrational numbers are much, much higher than the rational numbers, if you say so, right? So basically, yeah. You can find many, many, many rational numbers. Just give me a second. Right? So, this whole system, irrational numbers and rational numbers, create the real numbers, right? Apart from these real numbers, we have another one outside real numbers. We have complex numbers. So we will learn them eventually in your first year, second semester. You will learn complex numbers, right? So the whole image insists with complex numbers, and then complex numbers we have then real numbers. Inside real numbers we have irrational numbers, and then we have rational numbers, right? So real numbers can be divided in two parts: irrational numbers versus rational numbers. Inside rational numbers we have P over Q values, right? And then we have integers, then we have whole numbers, and then we have natural numbers, right? So the real numbers are represented as with the Q. පරිමේය සංඛ්‍යා කියලා අපි කියනවා. Right? Irrational numbers are Q prime or Q dash, right? Whole numbers are with W, natural numbers are with N, right? So there is a sort of nomination representation methods for these types of numbers, right? So we have real numbers, we can use R here, right? For the complex numbers, we have C here, and then irrational and rational Q prime or Q dash, and then integers, we have Z. For whole numbers, we have W. Natural numbers or counting numbers, we have N. So that is how the number system that we are working with consists or it's created, right? And then the most important thing, right? So in mathematics, it's not always that we can work with these non-terminating values, right? So therefore, we have to consider these non-terminating values to some sort of approximated values, right? So we are approximating our values in a manner either truncation or rounding, right? Truncation or rounding. So in the case of truncation, so we consider a certain limit and then drop all the digits after that particular one. So let's say we want to truncate this one to 2 decimal points. We can 3 decimal points. We can consider 1.414, and we can disconcern the other decimal points after that. So that's truncation. And then rounding. So we can consider the decimal point that we are looking at, and then we are looking at the behind value or the prior value to that one, right? The smallest value. And depending on that value, we can either round up or we can either round it to the upper side or the lower side, right? Okay. So the case is that the convention is that if it is 5 or larger, we will increase the value that we have here. If it is less than 5, we will keep the same value as it is, right? Okay. And then from there on, we can truncate the other values also. So we can consider the previous decimal point to round up or down the upfront value, and then neglect all the values that we have afterwards, right? And then for our numbers, we know that they can be added, subtracted, multiplied, or divided, right? So some words are there, sum, difference, product, and quotient, right? Quotient, someone can say quotient, but it's pronounced as quotient. So sum, difference, product, and quotient are 4 operations that we can carry out on the numbers that we are talking here with, right? Shall we try to evaluate these values and let me know the answers for these values? Hurry up. So you can put 4 answers in the chat box. Yeah, we have some answers here. For A, so this is not a decimal point. This is a product. Make a decimal point and make a product. Decimal point. So the decimal points are in the line of 8 and 2. Right, somewhere here. This is not a decimal point. This is a product. So I took an answer from Mithila. So let's see what Mithil has done, right? Okay, I'm happy to see many answers here. So what happens here? For the first one, Mithila said it's 19. That means 8 times 2, and then plus 3, it's 19. And for the set, this one, he had 37. So we have parentheses here, 3 plus 4. That means 7. 7 times 5, 35. Plus 2, 37. And then here we had 2 plus 5, that means 7. And we have 4 plus 4 times 7, it's 28 plus 30. So that's 30 over 7. 7 never 30. And this one here, it was 37. And then we had 10 plus 6, 16 times 2, 32. 32 plus 4, 36. 36 plus 2, 38. So now, how did Mithila and myself got the same answers? So did I ask Mithila to prior to the class that you should answer these 4 questions in this manner? No, because there is a method to do this kind of calculations. So there is a convention, there is a method, there is a rule, there are some rules, right? So Mithila and myself, we both did the same way. That's why we got the same answer. So if all of us followed this one, so we should all get the same answer, right? Let's look what are the rules that we are looking at, right? So they are called order of precedence or order of operations, right? So we have to begin with the innermost parentheses. Parentheses kila kiyanne warahan. So these are parentheses. So there are several types of parentheses, right? Square ones, parentheses, curly brackets, right? Those are the 3 things that we have usually encountered with, right? So we have to start with the innermost. Look at this one here. So the innermost one is here. So it will get the priority. 10 plus 6 get the priority. And here also they get the priority. And something we had in the numerator and denominator. So the upper part is called the numerator, right? Api English in numerator, you know. And this one is denominator. So when we have numerator and denominator, we can put brackets if we want, right? Essentially, we don't have to, but we can put, because numerator and denominator are 2 separate portions that we have to look separately, right? Okay, so we can treat them as they were inside the parentheses. So we can do this separately, we can do this separately, right? And then multiplications and divisions first, working from left to right. So from here, from left side to right, left to right, left to right. So starting from here, we do the calculations that occurs the first. So we occurred the multiplication first here. So we do the multiplication of 8 plus 2. And then additions and subtractions once again from working from left to right. So what will happen here? 8 times 2, 16. 16 plus 3, we get 90. Look at here. So we have to start with parentheses, right? So the parentheses here, we have 3 plus 4, it will be 7. And then we have the multiplication here from left to right. 5 times 7, 35. 35 plus 2, 37. And here also we can see we can do this part, and we can consider this one is the first one. 4 times 7, it's 28. 28 plus 2, it's going to be 30. 7 over 30. So this is how we should do this kind of questions, right? Okay. So these are the questions that you can try, right? You can take a screenshot. So let me put it in full screen. So you can take a screenshot of this one here. And you can try from question number 51 to 88. So these questions are from the Sullivan's book, right? So that means you can if you download this book, you can have as many as questions you want to try, right? Right. I suppose you have taken taken a screenshot of this one, right? Okay. So you can try these questions and you can download those books from internet, and you can try some other questions also, right? So for today, we will stop it from here, right? So next day, I will do some algebra that will be useful in our coursework. And later on, we can go into core things that we are going to do in our lecture module, right? If you have any questions, you can send me an email to my email address. You know my email address. So I will write it here once more. Right? Other than teaching in Sinhalese, okay? You don't have to let me know whether I should be teaching in Sinhalese or English, right? Yes, I could have taught you in Sinhalese also, but I'm not going to do, because I will be manipulating your willingness to learn in English. So I want you guys to start from now and trying to understand many things as possible using English, right? So if anything is to be discussed, you can let me know. Otherwise, we can stop it here. So I will give you some time to ask me questions. And if you don't have, we can stop it here. Right. For the attendance, usually you can put your index number here, right? So please put that one. Thank you very much for remembering that one, right? So please put your index number there to get the attendance. right? If you don't have anything to discuss, you can leave the chat. You can leave the lecture, and we will meet probably. Yeah, I will get some classes probably in the free slots that you have, right? So I will communicate through both the WhatsApp and the email groups, and be alert on those two, and I will let you know. Usually I will let you know the day before, but today I didn't plan to have your lecture, but I had some free time, so that's why I had to inform you somewhat later. But in the given time slot, usually you should be ready to have your lecture. Okay, right. So then thank you very much. Please put your name for the attendance, and we can stop it here, right? Okay, thank you very much.